Let's look at a couple of problems. We're subtracting rational expressions. Um, and there's one thing we kind of need to keep in mind that we'll see on our second example coming on up. Adding or subtracting rational expressions, we have to ensure that they have a common denominator. And this problem has a common denominator. So then what I'll do is I'll take 2x plus 3 minus the numerator of the other side, combine them on the same common denominator. Simplify means look for like terms. Are there any like terms in the numerator? There's a 2x and an x. That just leaves just an x. So I have an x plus a 3 over an x plus a 1. So seems fairly straightforward. Now where it could get a little tricky is on an example that I'll show right now. So 5x plus 1 over x squared minus 9. Subtract 4x minus 2 over the same common denominator. We'll deal with different denominators later. Okay, common denominator, check. Numerator, I take the first polynomial minus the second polynomial. 5x plus 1 minus 4x minus 2. Okay, alert, alert. Be very careful right here. Writing what I just wrote is wrong, but we're going to feel like it's right. And let me explain to you why, so you never make this mistake. Now notice I'm subtracting this entire polynomial. Subtracting the entire 4x minus 2. It's part of a summation. So I need to subtract. When I subtract, I'm not just subtracting 4x. I'm subtracting the entire 4x minus 2. Well, what's that matter, Willie? Well, if you noticed, if the parentheses weren't there, it would just be a minus 4x and a minus 2. But with the parentheses here to remind me it's part of a whole, I am now going to have 5x plus 1 minus 4x. This negative distributes over to the negative 2, and I get a positive 2. If the parentheses were not there, or if I was careless, I would be left with a negative 2 at that point, and would start down a road of solving an incorrect problem. From there, let's just continue on and looking for ways that we can reduce that down. 5x minus a 4x gives me an x. Constants add to a 3. I see an x squared minus 9. I already see a common factor in that. If I were to factor that out, that factors out to an x plus 3, x minus 3. And since I see a whole factor on the top, which is part of my sum, x plus 3 cancels out with the, or factors out with the x plus 3, and I'm left with 1 over x minus 3 as my final solution.